Good morning, fifth graders. Today we're going to continue to work on mixed numbers and improper fractions, but I want us to put a little bit more emphasis on explaining today. I think a lot of us can really go through the process, but why? Why does this work? Why does 2 and 3/4 become 11/4? So I'm just going to actually put that up here just as a start. And I want you to think about yesterday we got really good at going from 2 and 3/4 to 11/4 or vice versa, but I want you to think about why. If someone said, explain this to me, why does this work? How would you do this? I want you to think about an extended response. If I asked you to write a paragraph explaining how you went through this, could you tell me? So I'm going to give you about, 10 seconds or so to think through this and think about how you would explain this to someone else. Hopefully you have a bit of an explanation that you've come up with. There are a few different ways to explain it. I know that some of you know the shortcut where you can say, okay, well, 2 and 3/4. Some of you know the shortcut that 2 times 4 is 8, plus 3 is 11. So that's always our shortcut, is to multiply the denominator and then add the numerator. But why? That doesn't really explain it to anyone. If I said, hey, multiply 2 times 4 and then add 3, they'd say, well, why does that work? Well, one way I think you could explain this to someone would be, well, if we're working in fourths, I know that 4/4 equals 1 whole, right? So if I have 2 wholes, I know that would have to be 8/4. Because 4/4 is 1 whole times 2, give me 8/4. So I know that I will have 8/4 because that's my 2 wholes. And then I have this 3/4 just hanging out left over. So then if I took, and I'm going to put it right here, that 2 wholes, which is 8/4, 8/4 plus 3/4 equals 11/4. So if I had to write a paragraph about this, I would say something like, well, I know that if I'm working in fourths, 2 wholes would be 8/4. So that would give me my 2 wholes. And then I see there's another 3/4 remaining. So I need to add those 3/4 to the 8/4, and I get 11/4. I'm going to give you guys one more problem, and I want to do the same thing here to see if you could walk someone through this. So let's do, it's going to be fairly similar. I want to see if you could give someone a step-by-step walkthrough on this. Now that I've given you a few seconds to think, hopefully you've come up with some sort of answers, such as, again, I know that 4/4 is 1 whole because I'm working in fourths. 2 of those wholes would be 8/4. And then I have 1/4 left over, so I need to add that to it, and it gives me 9/4. But now the question is, what if I asked you to go the other way? What if I gave you the improper fraction and I asked you to change it into your mixed number? So first of all, I'm just going to start with the improper fraction, see if you can get into the mixed number, and then explain why. I'm going to see if you can give this into a mixed number. Hopefully you were able to look at this and say, well, I know that 3 goes into 10 3 times, because 3 times 3 is 9. So I can pull out 3 wholes. If you needed to, you could have done 10 times. Again, it would take quite a bit of time. We've talked about, guys, about how as these numbers get bigger, this strategy just really doesn't work. But I'm going to use it just to kind of show you. 2, 3, 4, 5, 6, 7, and then I'm going to come down here. 8, 9. And now you see why as the numbers get bigger, this just isn't the best idea. But for me to kind of visualize it for you or help you visualize it, this is an okay way to show. So here's 3/3 is 1 whole. Another 3/3 here would be 2 wholes. Another 1, and I'm going to borrow this guy. 2 3/3 is 3 wholes. And then I have 1/3 left over. So 3 and 1/3. Another way I could think about this, and hopefully we can push ourselves to start using our math facts, which is why we've been practicing, is to go to, well, I know the closest I can get 3 can get into 10 without going over would be 3. Because 3 times 3 is 9. So I would, if I took away my 9/3, I'd have 1/3 left over. So if I was to try to explain this to someone, I would say, well, I know that with 10/3, I can pull out 3 wholes. 3/3 plus 3/3 plus 3/3. 1 whole, 2 whole, 3 wholes. And then I know that 3, 6, 9, I would have 1/3 left over. So it'd be 3 and 1/3. So we're going to continue working on this today, converting between the two and explaining why. So your math today is going to look a little bit different. It's going to be less problems, but more explanation. We're going to work on walking people through this step by step. We're also going to work on explaining why. We got really good at solving, but we really need to work on explaining our work. It's one thing if you know how it works, but why does it work? So what if I said change 8/3 into a mixed number? I'm going to pause for about 10 seconds again. And I want you to think about how you would explain this to someone. Think about someone that's never done this before. How would you explain this to them? So hopefully you start with pulling out wholes, right? In this case, we know we're working in thirds. So if you really want to visualize this for yourself, you could say, okay, I'm taking out 3/3. That's 1 whole, right? I took away 3, and I'm just going to leave little notes up here. So that leaves me with 5/3. Does 3 go into 5 again? Yeah, I can pull out another whole. Okay, I took away another 3 up here. Ooh, now I'm down to 2/3. Well, I can't pull out another whole, so I'll write it down here. Plus 2/3. Now let's double check and make sure. 3 plus 3 is 6, plus 2 more is 8/3. Okay, great. You can solve it, but how would you explain this to someone? I might say something like, well, I know that with 8/3, I can pull out 2 wholes because 3/3 makes a whole, and 2 wholes in this case would be 6/3. I would have a remaining 2/3 left over, which would give me 8/3. So I know my mixed number would be 1, 2, with 2/3. 2 and 2/3. Remember, we're talking about the and here, how it kind of glues the mixed number together. I'm going to give you one more practice one, and then we're going to try this on our own today using our best explanations. I'm going to give you some words that I hope you use in your explanation. A whole. Maybe you use the word fraction. Numerator. To remember is your parts that you're talking about. And then your denominator, which is what your whole is split into. Maybe you use the word add, because we are definitely adding fractions in this case. Maybe you use the word total. Let's see here. Maybe you use the word, you could use simplify. You could use improper and mixed. Improper fraction to a mixed fraction. And I'm going to leave this right here for a second. I think it'd be helpful if you wrote these down in your math notebook, or maybe took a little screenshot so you know what words you want to use in your explanation today. So I'll just stop here for a second and give you about 10 seconds, 20 seconds to write this down or screenshot, jot it in your math notebook, wherever this would be helpful for you. All right, hopefully we got those words written down. That's a great word bank to use today for your explanations. I want to do one more problem. You're going to see some word problems today too that you have to explain. So we have a problem here that says Jonah was running around a track. He ran around, which is actually true in real life, 1/4 mile track. And actually each track in high school or professionally is a 4th mile track. He ran around the track, 15 times. So Jonah ran a lot of laps. So now we are asked to express this as a mixed number. So hopefully you know that a mixed number has a whole and extra remaining pieces, not just a fraction, not just a numerator and denominator. Okay, so here's what we got. We got Jonah. 1/4 mile is what we're working in. So I know right now I'm working in fourths. And he did this 15 times. I see my keyword here, times, so I'm going to do times 15. We want this to stay in fourths, guys. This doesn't change. We're not all of a sudden working in 60ths. We're still working in fourths. 1 lap is 1/4 of a mile times 15. He ran 15/4 laps. Okay, well that doesn't really help me. I have no idea what that means, but I can go to a mixed number now. So now what I need to do is I'm like, okay, he ran, each one is 1/4 or 1/4. He ran 15 of those. Okay, so now this is where I need to get it to a mixed number. I need to pull out my holes. Well, he can definitely run 1 hole. And again, if you want to do your little math up here, this might help you. So 15 minus 4, I have 11 left. So I can definitely take out another hole. Wow, so he's run 2 miles so far. Okay, I have 7 left. I could definitely take out another hole. I'm gonna take another 4 up here. Oh, wow. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But you see, I can't get another hole in here. I only have 3 left. So then that just becomes my remaining 3/4. So if I want to double check, 4 times 3 is 12. Add 3 more, I'm at 15/4. So that works, good. So I have 1, 2, 3 holes and 3/4 remaining. If you like to do it without visualizing and just using your math facts, which we are working up to, I'll erase this a little bit. I always like to leave that just so you guys have a couple different ways to do it. Another way to do it is, how many times does 4 go into 15? Well, I know that 4 times 3 would give me 12. 4 times 4 would give me 16. That's too much. So 3 wholes is as close as I can get. I'll write it down here. 3 wholes, which was 12, right? That give me 3/4 remaining. So we're gonna have a little bit more practice with those word problems today too. Just please, please, please continue to explain why today. Our focus is how did you solve it and why? Why did you subtract? Why did you multiply? Pretend you were explaining this to someone that's never seen it before. Okay, really use your math words, really give in-depth directions and explanations.